Hello, our little algebrainiacs. Welcome to the Johnson-Kendall video hour.
But it's not an hour. Although with all these steps, it could maybe turn into
Yeah,
an
looking
hour.
like we got 9 things to write down right off the bat. So, this is about synthetic division. Remember, the word synthetic means man-made. So somebody made up a way to do this long division, doing it a short way, a shortcut. So, I'm going to give you a few seconds here to write these down. Just kidding. You might want to hit pause. But here are the steps to synthetic division. You can abbreviate a little bit and just write down what you need. It looks daunting, but you're going to end up really liking this method. I promise.
All right.
Okay, welcome back. And we're back. Okay, we're going to go through these steps. The first thing you do, ooh, where'd it go? Come back, little lady. All right, first thing you do is you find the zero of the divisor. That's what we're dividing by. So x minus 1 equals 0, so x would be 1. And we put it into what we call the press box. Press box looks down on the field, so that's what our number 1 is doing. Okay, the next thing we have to do is check the coefficients, or I'm sorry, check the powers that be and make sure they're in numerical order. 4, 3, 2, 1, and 0. So if there are any missing, you're going to have to put zeros in as placeholders like we did in long division.
Nothing missing though. So.
Nothing missing, so let's put down the numbers in front, the coefficients. So we put down a 1, a -2, a 1, a 1, and a -1. Then we put a big line underneath, and we drop down our very first number. Drop that all the way down. Okay, next thing we do is multiply press box times that number and write it under the next number, the -2. So 1 times 1 is 1. And then we add that column and we get -1. Start it over. Multiply -1 times 1. -1. Add. We get 0. Multiply. 1 times 0 is 0. Add. We get 1. 1 times 1 is 1. Add. We get 0.
Well, what the heck is the point of this? What are these numbers?
Well, glad you asked. So what we have done, remember how long division we ended up with a polynomial on top of the divide symbol there? Yeah, that's what we're ending up with here. It just doesn't look like it. But what we do with all these green numbers down here is we put our x's with it. And because we are x to the 4th, we're going to go 1 less. So this becomes x cubed. The next.
Now, this is like the coefficient.
Right.
A 1, so that's why we don't have to write it.
Yep, and then we have minus 1x squared plus nothing x, and then we have plus a regular 1.
So I skipped the x because it was a 0.
Right. And then the last number is our remainder, so because it's 0, we don't have to put anything down. So when you take and divide by that, you're going to end up with that. Not squares, but the actual answer.
That's really easy.
It is easy, and you get going fast, which is the only problem, because you might forget a little something.
You want to do this one?
I do, because I love this stuff. All right, first thing I'm going to do is figure out my 0. Set this equal to 0, and so x is -4. Put that in the press box. Next, I'm going to check my powers. I have a 3. I don't have a 2. I have a 1, and I have a 0 power here. So I'm going to have to put a 0 in for the 2. So x squared, I'm going to put a 0. So I have a 1 right here, then a 0, then a -13, and then a 12. All right, put the line down, put our addition, and drop this one down. So multiply. -4 times 1 is -4. Add, I get -4. -4 times -4 is 16. Add, I get 3. -4 times 3 is 12. I'm sorry, -12. I add, I get 0. We like ending in a 0 because we got no remainder. Now these, because I started with x cubed, this is going to be 1 less. So this is 1x squared and minus 4x to the first power, but we don't write that, and then plus 3, and then we have no remainder.
Remember, if we have no remainder, that means that x plus 4 is a factor of that,
Right,
and you may be asked
fits
that.
in perfectly.
Right.
All right.
Okay, next part is called the remainder theorem. So, what the remainder theorem says is, if you divide a polynomial by a factor, they call it in the textbook x minus a, then the remainder is the same as p of a. Now, don't be confused by the p. They use p for polynomials. That's the same thing as having like f of a or f of x. So remember, when you have f of a number, like for instance f of 5, all that meant is we would go and substitute 5 for all the x variables and simplify, and we would get one value. That's the output for our function at this number. So what the remainder theorem says is if you put this number into the press box and do synthetic division, then the answer that we get for the remainder is going to be the same as that.
Substituting
Right.
would have gotten us otherwise.
Right. In other words, the remainder is the same as plugging in a to the polynomial. So here's what the questions are going to look like.
Woo! Freak out, freak out.
Trouble with my scrolling. Technical difficulties. Oh, of course.
Weird.
Okay, let's just hang on 1 second. There we go.
There, nice.
Alright, in the last example, we divided by x plus 4, so the 0, which Mrs. Kendra determined for us, was negative 4. And remember, the polynomial, that's why we're calling it p of x, was x cubed minus 13x plus 12. So if we asked you to use synthetic division and the remainder theorem to find p of negative 4, what you want to do is look back, and it would be the same thing as the remainder that we had, which we had a remainder of
0.
0. Okay, so I've already done the work to come up with that, but I want to show you that that really does work. So right now what I'm going to do is check. I'm going to show you why it works. Finding p of negative 4, that means taking negative 4 and substituting for my x's. Using order of operations, if we were to raise negative 4 to the third power, that's a negative to an odd power, so that will stay negative.
Right, negative, negative, negative.
And then 4 to the third is 64. Next, I've got a negative times a negative. That's going to turn to a positive. And 13 times 4 is 52. If I were to add 12 more, then you just go from left to right. I think that is 0. And remember, that is the same thing that we got for our remainder.
Right.
So synthetic division does really two things for us. It tells us what it would be if we divided by that polynomial, and it also tells us what the value of that function would be at that number.
Right. So,
you want to try one?
I do.
Okay.
So p of negative 4, all that's telling me is that goes in the press box.
And also what kids want to do sometimes is they want to change the sign. When it's remainder theorem, you just put that right in the box.
Right, right.
Not finding
So
0.
looking here, I'm missing the x to the third power, so I make sure I put in a placeholder. So I have 1, x to the third is 0, then I have negative 5, 4, and 12. So bring down the 1, multiply, add, then I multiply again, I get 16, which would be 11, multiply again, negative 44, add, I get negative 40, multiply again, that's 2 negatives, I get 160. So I get 172. Now all you have to do is look at the remainder, and that would be the answer if you were to substitute in for all these x's.
So if this is like a test or something, you should write this.
Right on. So synthetic division makes it easy to find the substituting. It's fast, it's quick, and then you don't have to worry about the powers or the signs or anything when you substitute.
Typing it in the calculator.
Right on. So synthetic division is very fun, very cool. You're going to love it.
All right.
Ta-ta for now.